Okay, I think I got it figured out. Something got switched in my settings for my microphone, like default, on my actual computer. So I think we're okay now. Let's start back up here. Let's get this thing back going here. Ooh, okay. Sorry about that. I think we're okay. All right. I want to test out the audio here and see how that sounds with the music in the background. Make sure I can actually hear me. So I'm going to play for a second with me talking, blah, 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 yada, yada, yada. And then I'm going to pause it and go check on the stream here. Let's go. Go, 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 go. I'm going to turn it down even more than it was. Even then, I think it was too loud. There you go. That plane is humming in the background. It's like chill. Very, very chill. Okay. Cool. We're back. Sorry about that, you guys. Welcome. I hope you're having a good night. You can actually hear me now. What's going on? We're back. We're going to be jumping into the advent of code. Kind of a funny name. Um, a little like game here, I guess. I don't know. We're gonna try to solve some programming project or problems like we usually do on the channel for the past little while. And yeah, anyways, we're gonna go ahead and get into this one. Let's actually rename this to day one. Secret entrance. Okay. Let me know if you guys have done this one or you guys are doing it along with me here. I will be honest, I did give it a read at work earlier, and I kind of think I have an idea of what to do already. So, for at least for this first problem, now they're releasing and dropping two problems at a time, I think, is their new thing. I don't know, I've never done this before, so our first time. Woo, let's go try. All right, here we go. Day one. Secret entrance. The elves have good news and bad news. The good news is that they've discovered project management. This has given them tools they need to prevent their usual Christmas emergency. For example, they now know that the North Pole decorations need to be finished soon so that other critical tasks can start on time. The bad news is that they've realized that they have a different emergency. According to their resource planning, and none of them have any time left to decorate the North Pole. To save Christmas, the elves need you to finish decorating the North Pole by December 12th. Collecting stars by solving puzzles. Two puzzles will be made available on each day. The second puzzle is unlocked when you complete the first. Each puzzle grants one star. Good luck. You arrive at the secret entrance to the North Pole base ready to start decorating. Unfortunately, the password seems to have been changed, so you can't get in. A document taped to the wall helpfully explains. Due to the new security protocols, the password is locked in the safe below. Please see the attached document for the new combination. The safe has a dial with only an arrow on it. Around the dial are the numbers 0 through 99 in order. As you turn the dial, it makes a small click as you reach each number. The attached document Your puzzle input contains a sequence of rotations, one per line, which tells you how to open the safe. A rotation starts with either an L or an R indicating whether to rotate left towards lower numbers or right towards higher numbers. Then the rotation has a distance value, which indicates how many clicks the dial should be rotated in that direction. So if the dial were pointed at 11, a rotation of R8 would cause the dial to point at 19, increasing it by 8 points. After that, a rotation of L19 would cause it to point at 0. Because the dial is a circle, turning the dial left from 0 one click makes it point at 99. Similarly, turning the dial right from 99 one click makes it point at 0. So if the dial were pointing at 5, a rotation of L10 would cause it to point at 95. After that, a rotation of R5 would cause it to point back at 0. The dial starts by pointing at 50, so dead in the middle. You could follow the instructions, but your recent required official North Pole secret emergent entrance security training seminar, jeez Louise, holy crap, taught you that the safe is actually a decoy. The actual password is the number of times the dial is left pointing at 0 after any rotation in the sequence. For example, suppose the attached document contains the following rotations. These rotations would cause the dial to move as follows. From 50, the dial is rotated to 82, then to 52, then to 0, then to 95, to 55, to 0, to 99, to 0, to 14, to 32. Because the dial points at 0 a total of 3 times during this process, the password in this example is 3. Analyze the rotations in your attached document. What's the actual password to open the door? All right, this one looks fun. Long problem, long read, but I think we got it. I don't know. We'll find out. Let me know if you guys are here with me. Got no chats today. Jeez, everybody's so quiet. What's going on? Where everybody at? Where everybody? Okay. So this is what I'm gonna do. We're gonna have an array which is equal to a list range object to 99. Sorry, to 100. We're going to include 99. Yo, Ray! I can always count on Ray to be here. What's going on, dude? What's going on, boy? Big Ray. I like that. Okay, so we're going to range up to 99, up to 100 from 0, and then list that value. List that, right? Hey, how's it going? Thanks so much, Abel Asp. Thanks so much. I appreciate you. Yeah, we're going to go here. So the thing is this part right here is kind of is the only thing that is what makes it a little bit more work. I think that this part is really easy. I could eat my words here, but let me try something here. So let me go like this. Let me also have a moves. I'm going to have an array of moves, and I'm going to have these moves. Let me take these bad boys here. Okay. L30, R48, L5, R60, L55. Oh, I suck at this. Oh, come on, get back here. L1, L99. Almost there. Stay with me. R14 and L8, 82. All right, so we just have these lists of moves, right? Kind of setting things up here. So the thing is I think it's as easy as this. If we start I at 50, well, at least for not this part down here, because I think that we could, if it was just asking for what it was asking at the beginning, it'd be pretty simple, I think, by just summing the moves and yeah, just summing the moves and then using a little bit of modulo functionality. So, okay, here we go. So we're gonna say for move in moves. We'll say if L in move, right? This is gonna be a leftward facing move, so we're gonna say so at the L in the move, this indicates a negative move. So what we're going to do is just slice the move from num is equal to, or we'll say, yeah, num is equal to a slice, an int. And we'll take the move and we'll take a slice of it from 1 forward. And then we'll leave it at that. And then we will go I think so. We'll just do this -1 times that, right, for a leftward facing move. Then we're gonna take we'll do like that. Else num is equal to, well, I guess we could just do this. We could say num equals to int move. So we're gonna have to do it no matter what. We'll slice the move from 1 forward. If it is 1, we'll just do num times times equal -1. And then, or I guess we could just say, can we just say equals to -num? And then we could else it's just num, right? So we can just leave it at that. Yeah, cool. All right, so now if we go ahead and simply, like, this isn't part of the problem, right? But I mean, we can actually solve the problem right here, I think, right? So we're gonna do this. I plus equals the num. If I equals to 0, we're going to count plus equal 1. We set the count equal to 0. We're just gonna print the count here. I think this probably does it. Let's kind of think here. Are we missing anything? We're starting I at 50. For every, oh yeah, we are missing something. Come on, Mike. Chill. You're going way too fast. I'm moving too fast. We want to do. Well, actually, that does it. That solves the thing, because if we wanted, if it wanted the actual part at the beginning, I think what we would do is something a little different. But let's see if we get this. 2. We missed 1. Okay, so let's go through and print. Let's go ahead and print I here. Oh, I'm sorry. Starts at 50, rotate at L68 to point at 82. Oh, sorry. Yeah, we need to implement the circular array part. Yeah. Okay, so then. Oh, but wait. I'm being dumb. I'm being dumb. Because we want to. We want to have our array be circular, right? And so we would need to do. We have a number to move, right? And we want to add that to nigh, and then we want to do. Now, can we just do I equals to I mod n here? I mod the length of the array. And then let's see what happens to I here. 82, 52, 0, 95, 55, 0. Oh, perfect. Oh, beautiful. That just solved it. All right, we solved it. It's done. Okay, so what's our moves that we have to solve? So all we had to do is just take a I mod the length of the array to make this circular, so that basically as we sum up values in every loop iteration, we're going to reduce that value to its lowest level of magnitude within the array sequence here, right, of 0 to 99. So think of it. I've been getting a lot of practice with magnitude stuff when I've been learning C and getting some more familiar with binary stuff. It's kind of been forcing me to do that, and so yeah, and we've been using the modulo a lot in the C programming book. It works a little bit different in C. We couldn't do this in C because C doesn't have the negative array indexing like Python does to make this work. But yeah, so what are our moves that we have to solve for? We have an attached document. Did I miss it? Oh, get my puzzle input. Oh, does this, hold on, I don't want to, I'm just going to be safe just in case. Okay, this is our input. Okay, so let's do this. Let's import requests. Yeah. Why is it doing that? Right. Let's do response is equal to request.get. We're going to get this guy here. And then we're going to print the response. What's going on? Am I being dumb? What's going on? Why don't I have requests in Python? I thought this comes standard, no? Am I being dumb? Am I being dumb? What's going on here? Oh, it's not standard. I thought it did. I'm trolling. It might not be. Okay. Sorry, guys. Let's Python dash m venv dot venv. Let's go. Yes. Let's trash this guy. Open up a new term. And then let's do pip install requests. All right, sorry guys. I thought that came standard. I'm trolling. Okay, now let's see what we get. All right, so we get the response object. Can we response dot to? Can we list this response object? Does that work or no? Puzzle input differs by user. Please log in. Oh, it's specific. Oh dang, I can't just import this with the request. That sucks. That's cool. They have a response that you get back. If you try to do it that way, they kind of thought of it. Holy Moses. It's a long response. Okay, I think I got it all. Command C. Okay, now let's go into, let's open up a file called moves.txt, I guess. Let's dump these bad boys in here. Okay, we got over 1,000 moves here we're gonna make. We're not gonna do requests then, that was a waste. So whatever. Let's just do from we gotta do dot moves. Is it dot moves? Oh no, sorry. We need to do I'm being stupid. With open, we're gonna open we'll move this into here. I guess we'll make a new file called day1. We'll take these guys and we'll throw them in here. With open moves.txt as, or no, we just give it a mode, right? I haven't done this in a while. We want to read as a file. We're going to say file dot read lines. So this will give us a line and list, and then let's do let's print this and see if we get it here. Ah. Go CD 2025 slash day one. Then I'll run this. Ah. Moves.txt. Ah, man, why am I getting stuck on this part? Importing the dang file. It's in my same directory here, I thought. With open, whatever, we'll just do the relative path. Advent of code slash 2025 slash day one slash moves.txt. Now can we run this? What? Why do I suck at this? Ah, there we go. Okay, so that gives me these with the delimiters. I think I want to dot strip. I think we can dot strip here. No. How do you, oh, I forgot how to do it. I forgot how to do it. Remove \n from readlines.txt in Python. Okay, we have to do a strip on each line for lines, or just do read.split lines. Okay. So let's just do read, and then do dot split. I need to get better at these file IO functions, honestly. I honestly forget about them quite often. Cool, that gives us all of our values. Nice. Okay, so now if we go ahead and make our, this is going to be, let's go comment out this guy. And let's go ahead and make moves is equal to here. And then let's run. 11:05. Yo, let's go. That's what I'm talking about. Hey, that's what I'm talking about, mate. Let's go. Oh, boom. We threw the second cut. Mr. Tim, we into the second cut. We coming through. We going in. We're going in. Into the second cut. Alright, that wasn't that bad. But honestly, the hardest part was loading the file. Alright, cool. Let's roll. Okay, part 2. You're sure that's right? That's the right password, but the door won't open. You knock, but nobody answers. Nobody there. You build a snowman to think while you think. As you're rolling the snowballs for your snowman, you find another security document that must have fallen into the snow. Oh no. Due to the newer security protocols, please use the password method 0x434C49434B until further notice. You'll remember from the training seminar that method, whatever that is, is that a binary number or is that is that a memory location? I think it looks like a memory. I don't know what that is. It looks like, I don't know. We'll find out. Means you're actually supposed to count the number of times any click. Method means you're actually supposed to count the number of times any click causes the dial to point at 0. Supposed to count the number of times any click causes the dial to point at 0, regardless of what happens during the rotation at the end of one. Oh, so if it passes by 0, you remember from the training seminar that this method means you're actually supposed to count the number of times any click causes the dial to point at 0, regardless of what happens during a rotation or at the end of one. So any time that we click past 0 in our movements. Okay. The following, for the same rotations above, the dial starts at 50. The dial is rotated L68 to point at 82. In this rotation, it points once at 0. Got you. Okay, let's think about this now. We'll say my answer, correct answer for part 1, for problem 1, 1105. This is for me. My correct answer for problem 1. Okay, or part 1, sorry. Okay, so if the number, okay, gotcha. So listen, if the number of that where I is currently on, right? We want to look at I that was on and look at I that it was not on before, right? Right, rotation 1000s. Okay, that's my next question is you can have, how large of a rotation can you have? So like if you rotate 1,000 clicks, well, like you can, okay, got you. Oh, this one's a little bit trickier. Dang. Just leveled it up a notch. Let me think. So what do we have that's currently, it's telling us, right? After each iteration, well, if R was 1,000, if we start off at 50, right? So in this case, let's comment this out. Let's make a new moves value, and let's do R1000 here. Right. So in my example, in my previous code, if we did this, we land back on 0, right? and I is initially 50 to start. It stays. It goes in evenly. Turn back to 50. Print the count to 50, and I is at 50 still. So end up back at 50, and then the count was 0. But that's not true, right? Now if we take, so I'm gonna say print quote. We'll do an f string. I is equal to we'll just wrap this here. Okay, and then what I'll also do is I'm gonna say in this pass, I'm gonna say print I divided by the length of the array. And then I'm going to print here for this guy, I'm going to say tester. Can we get how many times .5. So I in this case is 50. Length of the array is 1. So my tester is 0.5. What? Why would that be the case? Why would that be the case? Just doing just I divided by the length of array. Oh, the length of array, sorry. Length of moves. Oh yeah, this is doing the array, right? Now what if we did length of moves? How many moves? No, because we want to be the length of the num. We want to do the in reference of the number itself. But this would be 50 divided by 1,000. Right, which would give us 0.5. Now if we did, but it only did it, we're ending up back at 50. So if I just did times, that would give us to the 50, right? No, 50,000, right? So if we take I, in this case is 50, and then num is 1,000. So then if we just do num, mod I here, that'll give us 0. Sorry. Yeah, because 50 goes into 1,000 evenly. But how many times we want to do a division here, which is 20. But that doesn't really tell us how many times it passes 0, right? So I don't think, and this wouldn't really like work. Well, maybe it would for like numbers that aren't, maybe it's just convenient because these, divide into one another, right? How could I identify if the sweep caused it to go? Now the thing is you have to track how many times it goes through. Because if it gets fairly, well, if R is 1,000, right? Okay, so hold on. Sorry, I'm being dumb. If R is 1,000, right? If R is 1,000, and if we're rotating 1,000 in either direction, starting at 50, um, I'm sorry, let me think. The dial we're pointing at 50, a single rotation like R 1,000. How many times did we pass 50? Well, every time that we passed 50, we did pass 0 as well, right? A 1,000 divided by 50 is 20, and we only passed it 10 times before returning back to 50 in this example. But we did 1,000 clicks, not 1,000 rotations. Right, 1,000 clicks is not 1,000 rotations. It's the number right, it's 1,000 clicks, not rotations. It's clicks. So you have to, and then, so in our previous example, we identified I, which was the total magnitude, basically, of, so let's go back to this guy here. Let's do this. Right. So we're at 82, 52, 0, 95, 55, 0, 99, 0, 14, 35. Now this just means that we were at an 82. And then if you were to mod that by the length of the array, it would tell you what magnitude at this iteration that would line up. No, sorry, we already did that. That's already what's happening here. Yeah. So we're on the number 82 physically. Now if we moved here, we did move, 30 units down. We did not pass 0 because obviously we didn't go into the negative. Now if we ended up well, actually, what if we... No, because so it is move dependent on a singular level. I don't think you can compare the moves from iteration to iteration, because that doesn't really tell us what we want to know at all, because it only tells you if it passed by it once, technically, in this current time. Now, what if we print out the number of I before we do the modulo operation here? Right, this is what we get here. Now on this one, we definitely pass 0, but we don't know how many times we passed 0, right? We definitely did do a pass 0. Now on this one, well, I guess on like every single case, you could have passed 0. That's what I'm saying, is like, you can't really look at it from iteration to iteration like this, because, at least I think in my head, because you can't tell how many times you rotated right past 0 just from these two numbers. You could have done it, you could have gone from the 52 to 52 again, then do 100, or you could have gone just to 52 to 100, or you could have gone to 52, 52, 52, 52 to 100, right? It just depends on the number of individual ticks associated with each move, right? So we would want to do the move, right? Let's print the num mod by the length of the array. We'll do if num is greater than the length of the array. Let's go ahead and print that number and see what happens here. So the number in this example doesn't actually hit it because it's just how this example happens. Now, if we open up this one, right, our number is 1,000, and we're dividing by, well, we're doing 100, right, which evenly divides into 1,000. So that's not really how it is. But we want to do, if we do division here of the number divided by the length of the array, that would give us 10, which is the number we're looking for here. So interesting, right? If we do the number divided by the length of the array, and you probably would want to floor this value because you don't have half zeros, right? Or whatever. You would want to have this floored. So if we do for our example of our this code up here, well, in this example, the dial pointer points at 0 3 times at the end of the rotation, plus 3 more times during the rotation. So in this example, the dial starts pointing at 52. The dial rotates to 68. The dial is rotated to 68. Left 68 to point at L82. During this rotation, it points at 0 once. Okay, so what if you do... Now, in this example, we get 0. It doesn't happen, right? Because I'm only looking for how many times it actually went in there. Now, what if it just passed it once? Right, that's the other edge case I think I'm missing, is if it just did it once. Right? So if it just passed by 0 once, then we want to figure out if the values... Well, no, because this would do like the num plus... This only just gets the move. This doesn't account for the current value of 50 we're on. Right, so this moves left 68 to bring us down, technically in the negative, but we're at 82 now, right? So we for sure have 1, right, in that case. Now, how can we determine that case? Is if 50 less than 68 is equal to what, like the absolute value is not... So if 50 less than 68 is equal to the absolute value, Oh no, we have to rotate it, right? Oh, this one's tough. Sorry, I'm missing some chats here. I've been just kind of focusing up here. Okay. Let's keep chugging and thinking here. Um, I don't think this. Well, I don't think this is it. It's definitely. It's not. I don't think that it doesn't have any relevance at all. This thing. Dials rotated L55 to point 0. The dials rotated L1 to point 0. Points at 0. During its rotation, it points to 0 once. So if the current value of I, which is 14 in that case, I'm tired. I only got like like 3 hours of sleep last night. I was up really late, goofing around, working on a React project, just getting the front end started up on my new project I'm working on. I'm gonna introduce it on stream soon here. But I was just sitting in my bed, just debugging this little thing, trying to work on some. I'm first time using some like pre-built React components rather than making my own. So I was kind of messing around with it. Just got kind of carried away. So I'm pretty cooked. All right. I'm losing steam quick here, boys. We're losing steam. Okay. um. So how can we determine? So maybe like it doesn't have. We can't even do it. Maybe we can, but maybe it's dumb of us to think about it like in just such a narrow direction of using mod and division, right? Because we're moving 1,000 clicks, which means that we know where we're going to end back up, right? We're going to make a move, add it to the number. So if we do 1,000 clicks, I keep like losing my train of thought, just thinking about other stuff like Wandernoy. Gotta like focus back in, keep myself going. So the thing is 1,000 clicks, right? Modulo by the array gives us 0, which means that we move back in the same place where we already are. right? And that's what's happening here. We're adding I to the number to I, and then we're like basically shaving off and keeping the remainder of like of what happened, right? Because we have the thing, we're making a move, we're increasing the dial, right? From 50 to like 100, which means we move at 50, and then we move on the value of 0. So the value of I tells us where we're currently at, right? So in this case, I at this point now points to the value on the dial, right? This is what I is on the actual dial. The number I plus equals the number here so let's print I here instead. Did I do this before already? Yeah, I think I did. Right. So we definitely did a change here. But the thing is you can't tell how many times you did the change, right? You can't tell how many, if the amount of rotations went. Well, if the amount of rotations is greater than 100, so if the number is greater than the range, that means we're going to do a full loop, right? And so by default, we're going to have a move there, right? If it's greater than 100. And so that's why I feel like we have two separate components. We have one for calculating moves if it's greater than 100, or one passes over 0 if it's greater than 100, and then one for calculating passes over 0 if it's just a shift within the same current range of 100, right? Right, if we're not like entering into a new loop, like lap, basically. Like that's what I'm trying to figure out here, is the lapping. Right. So the dial starts by pointing at 50. Then L is 60. L68 makes it decrease down into the negative. So if it's I think we have to do like I mod the number or something. Right? If we have I, the current value, modded by the number mod by I, so if we increase, no, let's do it before. So let's print the num mod by I here. Sorry, I mod by number. 50, 22, 40, 0, 1, 2. Just tell us. We started at 50. So this counts 6 zeros. If I is ever equals 0, like this counts 1, 2, 3, 4, 5, 5 zeros. Right? 1. Yeah. So we want to find out so we don't care what happens. So if I is equal to 0, we're going to, if I is not equal to 0, then I'm going to print this. I want to see what happens. It's 2 times. Why did I print twice there? Oh, because it doesn't print on that pass. I mean, there's 6 numbers that are non-zeros, but I think I'm just stretching for some coincidence here. um, I mean, does that make sense though? Like, so if I is 0, we don't care, and if I finishes on 0, we don't care. Or if the value is even, we don't care, right? If it ends back up. But if it has like a remainder, it passed over. Now, how many times? I'm not sure if that would really tell us. I mean, we can definitely put it to the test here with this guy. This would just give us the num 1000 mod 50, which is 0. It's not what we want. So that's not it either. Ha 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 ha. Sorry, I'm just talking through my words here. I haven't been really reading much chat, you guys. Sorry, I've just been kind of focusing. Definitely got me here. So, let's think. Let's just back it up and maybe break it down. And look at the example. So this dial starts by pointing at 50. Dial's rotated to the left 68. To point at now 82. It passed by 0 once. So difference of 18. I'm trying to think. I'm just struggling. The dial starts by pointing at 50 and we rotate it to the left, we pass 0. So what way can we record that also accepts for like also accepts like I think we were on the right track before because like we needed to accept multiple spins. So we need like a division, right, in order to determine how many spins took place if there was any full spins, right? Now, at what point in the loop do we do that determination? Okay, like for each number, how many full spins are we going to do, right? So if we say 0 passed is equal to 0, right? Let's make some space here. So we want to know how many passes we're going to do. So we have to determine, okay, the number floored or number divided by right, the array, length of the array. Right, so 1,000 divided by 100 gives us 10 full passes, right? Just in this example here. Now, number divided by the length of the array. So the number is 30 divided by the length of the array, which is 100. So if we say, like, if the number is greater than the length of the array, then we would do this operation, right? Because we know we're going to do spins, and we want to do how many. And then we need an operation floor. Do we care about the remainder? So in this case, 1,000 divided by 100 gives us 10. And that's how it works. Obviously, if it was 1,025 or something, we get 10 to be floored down. But if we didn't, it would give us a decimal. Now, do we care about that decimal? That's like a percentage, right, of the way through to the neck of a full loop, right? And so we'd have to translate that to ticks, and I don't think that's really what we want to do. So we probably want to floor. So if we floor this here, this gives us 10 total passes. Because if we don't want to do a mod on I mod number. This gives us the zero. Okay. Okay, modulo by 0. There goes east by even there. So we want to add this to the remainder of I modulo the length of the array. Well, the length of the array in this case is 100, right? I would go to oh, whoops. Screwed up here. Now, do you do the count? No, you're not including the count here. Do I mod the number divided by the length of the array. So 50 mod 68 would give us 13. Right, this gives us probably a pretty small number. Modulo by I, because I can be 0. We can't divide by 0. So then we would say like, no, so we want to take the none divided by the length of the array, I thought. And that value is how many loops we've done. Right, that's how many loops. And in those loops, you've done zeros, you passed zeros. Now you also are trying to determine if the remainder of any value left over makes you cross 0 again, right? So you have this, right? And then we also want to determine a summation of this with the rest of what happens, right? So in order to do that, we would want to determine the count plus the times it points at rotation. So is it just plus count? No. I don't think so. It's not as... I wish I could do an example. I wish you could do like a tester with something else that we knew an answer of that wasn't this 6. Well, this says it because it rotated during once. In this example, the dial points at 0 3 times at the end of the rotation, plus 3 more times during the rotation. So the count is the times that it points at 0. And then how many times it loops past 0. So maybe I'm just thinking about this wrong. Like, is this... Now, we would want to also determine, though, I feel like we might have a couple of errors, like off some edge cases or whatever. Not edge cases, but some other cases where you don't evenly split, right? Or you don't evenly go into, you don't land back on the same number, right? And so would, let's say you're at 99. Well, if you do 1001, well, you would land and your count would be there. But if you did 1,002 ticks, right? Well, you would rotate 10 times and then do 2 more, putting you over the edge from 99 to 1, right? So we would need to take the remainder but how could we determine if the remainder, so we need to take the remainder would we? Of the num, right? So this is loops, right? And then we would want to do the remainder after the loops, right? So we want to take the number plus so this would be loops is equal to this full loops, and we want to take the number of loops and get the remainder of the number that we have. No, we want to do I plus the number, right? Which would tell us the total position value divided by the number of loops. Do we just add it to I? No, I don't think so. Bro just came in here and acts like we haven't been using the mod function. Bro should probably like read the stream, watch the stream for a couple minutes. You should look into it, bro. I can't let chat trigger me. Okay. Trying to determine if we need to even get the remainder, right? I think I'm just solving too many things at the same time here, thinking about too many different cases and getting things confused. So this determines the number of total loops, right? Which would be, now for the case of if, like what if R, instead of in this example, was 10,052. Right. Now let's print also loops. Oops, loops. Alright, so you get 10 loops, I is equal to 2 at the end. Because you left off on 2. And your count is 0. But that's not, yeah, your count is 0, meaning that your times that you counted the number of zeros you landed on. You didn't land on 0 at all. We'll say 0 land count. 0 land count. And then we'll increase this. All right. Okay. Right. So You landed on 0 times. You did 10 loops, which means you passed 0 10 times. Just in that one pass, because we only have one value in here, not adding it already, right? I mean, we could do loops, so let's do 0 pass plus equal to loops, right? And then we'll just come down here. Right. Okay, 0 passed is 10, right? Now, in this case, I is at 2, but it was at technically like the 1,002, right? It got added to the number. Or 1,052, right? I became. And then it got truncated down to fit within our range. Right? Now, we have the amount of times we pass it, which is 10 times total. And we want to, so if we can, I don't like any like logic for like positive versus negative, but I don't think that that's really necessary. B0. Okay, so now if we say that 0 passed plus equals to the man, I suck. Trying here. I'm trying. 0 pass goes up by the leftover from the amount of loops, right? So I think it's the remainder of the amount of loops we did in this pass, but from what number? Is it from I? So 1,000. So 10. That would give us a leftover of 52. So if I print, say, here, and then do the number. No, we wouldn't want to do the number, I don't think, because so I don't think it goes there. I think we need to do it print after we increase print I mod the loops. That gives a here value of 2. So I mod in loops would be I is 2. No, hold on, let's print. I here. 1102, right? It divides by 10, it mods by 10, giving us a leftover 2 value. So no, that's kind of like the same thing I think we're doing just below. And that's by the length of the array, which so happens to be of a denomination of, 10. Magnitude of 10. So um so in this case, can we get 1? That would give us 102 back. No, we wouldn't want to do that. What would it be? Just I in this case divided by the number. I is 1002, we divide it by get rid of this. 5,000. Still get 1 for this guy. $1,050. Ah, shoot, man. I might need to come back to this one and think about it for a little overnight. I got no shame in coming back to it and thinking about it. I don't want to look it up. I want to really work through these and, simulate, sit in the library grinding through these. I don't want to, this is where the learning is happening as our brain is churning through different ideas, opening different doors, like peeking down different alleyways. Like we're trying to just find anything that works, and in that process we're debugging, we're learning, we're using print statements to go through our loops. Like it's really establishing that like skill set. So some people might argue and say, oh, it's a sunk cost, you should just at some point after like 30 minutes just ask AI. But I don't know, dude. Like I don't know. In the long haul, like maybe in the short term, like you might get like a short spurt of knowledge and be able to like do some stuff. But in the long term, I don't know if that really would work. It doesn't seem very viable. Dang. I don't really want to go too much longer because I was up real late last night. Hey Josh, how's it going? Hey Sanjay, how's it going? He says, are you learning programming for biochemistry or just for applications? Um, for both, I guess. I'm just learning for fun, really. Just I was tired of sitting at home doing nothing after work and forgetting everything I learned in college. And so I was like, well, do I want to continue studying chemistry and stuff, or do I want to maybe try something new? And I decided to try something new, and I've really started to enjoy programming and found a real passion for it here. Def better come back to it. I had to. Yeah, I'll have to come back, AJ. I feel like we're on the right track with like the number of loops being calculated, but we're just not determining appropriately that final leg that takes place, right? Well, the number here is 1,000, right? Or just, I don't know. I don't know. We might be close here. Mm, 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 mm. Well, interesting. So I want to see like what happens if we do L1000 here, right? Yeah, interesting, right? It goes in the opposite direction. And so the loops comes out to be negative. Actually, with Python, the oh, because that's happening here to the number. Yeah, here, right? So if the number is negative, maybe we don't want to always do this at this point in time. Well, I is always positive. So this leading value will never be negative. And the number here, the number could be negative here, right? If it is negative, then L. Right. So there's I is 1. That value is 1. We end up having a remainder of 1 from the number that we're on. No, because the number loops past. We have loops past, and then we have I, which is the current value with the number increased. we haven't truncated to our range yet. I think we want to do by loops. But what if loops is 0 here, right? If loops is 0, this won't happen. So if you made a loop, no, because you don't want to mod by loops, because I'm not sure. I just don't think it really applies this to. Maybe it does. Maybe I'm just. So the. I don't know. I think I need to come back. So this truncates the value down, right? I don't know. Maybe I'm not even. It's 10 loops. 5. Number. The number by the loops. 52. 10. Let's give me 2 back. Not what I want. Hmm. Hmm. Let me come back to it. I'm gonna be done here before 10 o'clock. Dang it. We got stopped in our tracks, boys. Ladies and gents, we got stopped in our tracks. It's okay. I'm not embarrassed to. I've been doing these streams long enough here, almost every day for the past year and a half now. Almost coming up on like what 400 videos on the channel, or almost 500 or whatever. So we've got. I've got experience looking dumb. Don't get me wrong, but no, we just need to think about it a little bit longer, I think, and figure out how we can. So if we make the number negative, right, the total number, to move it down by 1,000. Divided by mod. Say print, say here, we'll say the num by I. Zero. This one. So we got expand. Any significance? No. Dang it. So we need to divide, so that's the number. That gives us the length. That gives us the amount of loops we're generating on this hash. Now, if you have I don't know. I'll have to come back to it here. Yeah, in Python, I believe that the floor division operator will always drop the decimal in either negative case. I don't think that it makes it even more negative, like truncates it even more, like in C, to make it more negative. Right? I don't know that we can test it. Right, so this goes to -2. Right. Whereas if we did oh, it even goes, okay, so then if you do, so I just did this here, 1.5, and did this here, -2, so it made it even more negative, right? Yeah, it does do make it more negative, yeah. And then -50, where 100 would truncate this down to -1 from negative 0.5. Yeah. Whereas 50 divided by 100 will go to 0. Right. Okay, let me come back to this tomorrow, I guess. Or I'll figure, I don't know. We'll have to see. Hopefully I don't get stopped out on day 1, right? That'd suck. That would suck bad, right? Um, I know we need mod and we need floor, right? But just in what combination and with what variables and where at in the loop is the question. Like we need to determine how many loops occur over the dial itself, right? How many full rotations. And in determining the number of full rotations, we can figure out how much Hmm. Yeah. All right, you guys. Sorry, I'm trying to figure this out, and I appreciate you guys studying with me and hanging out. Um, yeah, dang it. Wasn't able to solve the second one here tonight. I'll have to think about it some more and come back. But thank you guys so much for being here tonight, and appreciate it. See you guys tomorrow. Let me know what you guys think. Peace out.